The height x meters above the ground of a car in a fairground ride at time t seconds is modelled by the differential equation dx dt is root x sine t over 2. The car is 1 meter above the ground when t is 0. Find the greatest height above the ground reached by the car during the ride, and find the value of t when the car is first 5 meters above the ground, giving your answer to 1 decimal place. So I've got the summary of the question here. We've already done part A in the previous part, so I've got the solution there for part A. Now the height for part B then, the height x is given by this differential equation, and it's the same initial conditions. X is 1, x is the height when t was 0. We put that in part A, and we got the solution here. So find the greatest height. Well, when is this greatest? Well, it will be greatest when this thing inside is biggest, won't it? And cos varies from 1 to minus 1. So if it becomes minus 1, this will become a plus, and we'll get 2 plus 1. X is max. Max is when max occurs when the cosine t over 2 is equal to minus 1. So for that to happen, t would need to be cos minus 1, cos of 180, which is pi, so t would need to be 2 pi, wouldn't it? Because cos pi is minus 1. That's the first time it hits the minus 1 value. Yeah, that's right. Goes from 1, cos goes from 1 to 0 to minus 1. So t is 2 pi then, is the first time that happens. So that's the, and when that happens, the greatest height is 3. So x max height, which is what the question is actually asking for rather than the time, is equal to 2 minus minus 1 is 3 squared, which equals 9 meters. So that's the maximum height then above the ground. Find when the height is 5 meters. So let's do that then. So part 2. Here 5 meters above the ground. When is this 5? 2 minus cosine t over 2 then is equal to, the height is 5, so that would be squared. So when we square roots, it's 2 minus cosine t over 2 is equal to root 5. A negative height doesn't make any sense in this context, so we'll just leave it with the positive height here. So that tells us then that cosine t over 2 is equal to, move that over the right hand side. I'm writing it down from right to left, so the 2 is left on the other side. Move the right root 5 over to be with it. 2 minus root 5. So now, cos, that's negative, isn't it? So let's draw a cast, C-A-S-T. Cosine is negative, cos is positive here and here, so it's negative there and there. So draw 2 lines, mark off alpha to the horizontal, and write cosine alpha is equal to, and drop the negative. So the negative dropped is just writing it around the other way, because that's the positive value of this, isn't it? So alpha then, it's shift cos this, so it's shift inverse cos of root 5 outside the square root minus 2 equals, now we're in degrees mode, we want to be in radians mode, so let's change mode to radians, equals 1.33, so it's 1.3 to 1 dp, 1.3 radians. So then alpha then, so t over 2, the angle in question, the cosine of the angle is here, it's around to here, isn't it, which is around 180, back the 1.3, and I'm going to write that slightly more accurately. It's 1.33 2 dot dot dot. So t then, the time, will equal 2 lots of this, pi minus the 1.332 dot dot dot. So I've got that in the calculator already here, so I'm going to click answer there. And I've got my answer there, so it's just 2 times then, bracket, pi, minus the answer, close bracket, equals 3.6 to 1 dp, equals 3.6, and that was to 1 decimal place. And that's the answer for the time. So go back to the question, check we've answered it correctly. Find when the height is 5 meters. So that's the time at t equals 3.6 value. X is equal to 2 minus cos it's 9. When the height is 5 meters to 1 dp. Oh, that's what we've done. We've done 3.6 there. We found the height there when it's 5 meters, which was 3.6 seconds. So just